Join the resistance!
Join the resistance!
Join the resistance? I don't know who's on my computer. I don't think this is the type of resistance we're learning about in electronics class. The type of resistance we are talking about, of course, is in an electrical circuit. Big questions we want to answer this time around. What actually is resistance? Why does it happen? What are analogies of what a resistance is like? What effects does resistance have in an electrical circuit? And then we'll have a couple more questions as well to help us try and understand resistance. As we said before, so we've learned about electricity, conductors, insulators, we've learned about voltage, we've learned about current. So resistance is the last big one that we're going to learn about electricity to really help us understand electricity. And it tends to be one of the easier things for us to understand about electricity. So let's dive in. What actually is resistance? Why does it happen? The definition of what resistance is, it's to counteract or repel. So if you think about it, there's all kinds of different examples that we could come up with of forces that counteract or repel. So if you're riding a skateboard and the skateboard is going, well, one force that's acting against that skateboard, we'd have wind resistance, that's resisting the skateboard. We'd also have friction on the wheels and the axles and so on. So now let's think about another example. If you're riding a bicycle uphill, well, gravity and also friction would be big resistance forces acting on those. So now let's think about more of an electrical sense. What does resistance mean, or what actually is it? So the unit we're going to use is ohm. We'll talk more about that in another lesson. And the definition, a measure of the difficulty to pass an electric current through a conductor. And when we say conductor, we're of course talking about like a copper wire or something like that. So let this simmer for a second. A measure of the difficulty to pass an electric current through a conductor. So what that means is we can actually measure resistance in a circuit. So why does resistance actually happen in an electrical circuit? Well, there's many different reasons why it can happen, or how we can increase or decrease resistance. We'll learn more about that in a future lesson. But the main thing you just need to understand is that there's basically, you could say, friction within the wire itself. So these electrons, they have to pass from one side to the other, and they have to flow. If there's things that get in their way, or if they're bumping into each other, or those types of things, that can cause friction. So some of you have probably noticed sometimes why when you touch like a copper wire, or there's certain other things, or even when you touch a resistor, sometimes those can be very hot, sometimes too hot to touch. So to sum up, basically, so why is there resistance within an electrical circuit? Well, basically because there's friction within an electrical circuit. Now let's think about some analogies. And we're going to have you pause here and think about this example here. We have two blue balloons. Think about what this has to do with resistance. Think ahead here. Now two blue balloons, let's pretend they're both the same exact size, they're both blown up the same exact amount. We're going to untie both and we're going to let that air out. On this one, we're just going to let the air out. We're just going to hold the balloon and do nothing else and just let the air out. And in this one, we're going to like kind of squeeze the end of the balloon. And then so I want you to think about which of these two balloons will let out the air faster. So if we think about that, this one, air is just going to go just out really fast. Whereas this one, when we're squeezing that air is going to have a harder time getting out. So if we think of about this balloon here, there's more resistance. So between these two balloons, this one, of course, would have the higher resistance. Let's look at another analogy. Two rivers, or two pictures, I should say. Both are the same river. Now in science class, you've probably learned about the effects that dams can have on rivers. So this is the river before the dam, and this is the river after the dam. In electronics, there's something called a resistor, and the resistor, of course, resists electricity. It reduces the flow. So according to these two rivers, in terms of what I've kind of been talking about, this one river, it's one river, according to this scenario, what would be the resistor in this scenario? What's causing the flow of this river to be decreased? So the dam definitely would be the resistor in this scenario. In this example, so imagine the water are the electrons, they're just flowing through nice and happy. You know, there's some other things that slow it down a little bit, like the width of the canyon, and maybe if there's some shrubs in the water, whatever like that. So there still is some resistance, but not nearly as much here, because upstream there's a huge, super powerful resistor that's really slowing down the flow of these electrons. So like the amount of current here definitely has been reduced because of that big resistor, and that big resistor, of course, is the dam. Here's another analogy for you. So here's another analogy for you. Think about a highway. So in this example here, let's pretend that the road is the wire. So then what do you think the vehicles would represent? The vehicles would represent the electrons, and those electrons would be flowing through the wire. And of course, the more electrons that are flowing, or the more vehicles that are making by, then the higher the current there is. Now, I want you to think about this. So there's different examples of how we could resist the flow of vehicles down a road. So I want you to think right now, what are some different examples of how you could resist the flow of vehicles going down a road? Some examples of how I thought about how you could resist the flow of vehicles would be, let's say if this road was really icy, or if it was really snowy, like the weather was really bad, ice, snow, really bad rain, that would slow these vehicles down. These vehicles would have a harder time. It'd be resisting them going faster. Another example of resistance for vehicles would be, let's say all the tires went flat on all the cars. It'd be pretty crazy, but that would also slow down the current. It would resist the flow of these electrons. The other example that I want you to think about, so it has to do with this picture here, try and answer, what would be a very significant example of something that could reduce the flow of vehicles going down a highway? And another example. So if the baseball is an electron and we throw that baseball down the field, between these two pictures here, what would be the resistor? What would be resisting the flow of that baseball in this example? Hopefully you noticed that the grass here is way longer and the grass here is shorter. So on the short grass, the ball is going to flow a lot more easily, have less resistance, less friction on the ball, whereas on this one the grass is longer, there's going to be more friction. So let's apply this a little bit more directly to how does resistance actually affect an electrical circuit. So we've seen this picture before, Mr. Amp, Mr. Ohm, Mr. Volt. Now the picture, Mr. Ohm is like squeezing that pipe, it's closing off that wire, and that's reducing the amps. So when we increase the ohms, that increases the resistance, which decreases the amps, which is the same thing as current. What will actually happen as well, so this side, there will be higher pressure, there will be more volts than on this side. So as I said before, there are ways within an electrical circuit that we can increase the resistance and also reduce the resistance. That's something we'll learn about in a future lesson. Thanks for learning.